Getting a map of directions from a starting point to some destination is a simple matter with various web mapping services. We can print out the map and textual description of the route, but still, when we're actually driving, it's hard to match the abstraction of the map and text to what we see in front of us. Given the wealth of visual information that has been gathered by driving along roads, we can now construct and deliver a video representation of the route along with the map and directions. After viewing the time-compressed and enhanced video, it is as if you had already driven the route once. Approaching an intersection, the driver's visual memory now kicks in to alert him that this is the intersection to turn right. Multiple companies are now driving the city streets in specialized vehicles. These vehicles are instrumented with cameras and other equipment capable of creating a 360-degree panoramic image every couple of meters. These panoramas can be strung together to create a panoramic video of evenly spaced frames along any route. By cropping the video to the forward direction, we see a simulation of what might be seen out the windshield of a car. Clearly, no one would want to sit through a 20-minute video to prepare for a 20-minute drive. However, just speeding up the video to a high rate results in a blur. Instead, since we know the location of turns and significant landmarks, we can automatically prepare a video that is retimed to slow down at points of interest, such as turns. One does not always want the video to simply look straight ahead. As we approach turns, for example, we can anticipate the turn by rotating the camera orientation in the direction of the upcoming turn. This both smooths the video and adds additional cues for the viewer. Finally, we are not restricted to the 90-degree field of view frustum. We use a variable field of view to open the frustum to take in specific landmarks as we pass by them. These peel-offs in the frustum are retained as snapshots to annotate the map and textual directions, which we show next. This is our map and video application. On the left you see a list of driving directions. For example, the first one is turn left on Brockmann-Goss. Now beneath each driving direction we've placed a thumbnail which represents that building or landmark for that turn. Now on the right we have a map, and on that map we've drawn a driving route shown in green. And along this route, we've placed the same thumbnails that you see in the driving direction. So the thumbnails on the driving directions corresponds to the thumbnails on the map. Now in the top center, we place the video that we computed earlier. And when I play this video, you'll see that the map and the video are synchronized together, and that the map will automatically pan and zoom according to the video. So I'm going to go ahead and press play now. Notice that the map automatically pan to the right position. The red dot on the map represents the current video position. And notice that as the video approaches a turn, the video is going to expand its field of view. So here I'm expanding to the left to show you that landmark on the left. And the idea is that this image is what we should try to remember when we drive. Here's another example. The image expands, and you can see the thumbnail on the left. Notice also that when we approach a landmark, the video slows down. But in between landmarks, the video speeds up, as you can see here. Now, as we approach a turn, the map also anticipates the driving direction. So as we turn to the left, the map is moving over to the left to show us more of the future route there. Here is another example. As we turn to the right, the map pans over and shows us the route that we're approaching. Now, if the distance between two landmarks is large, then the map will automatically zoom out and the video will automatically speed up. So watch carefully in this next example as we speed up and zoom out and zoom back in and slow down to show the next landmark. Now the map and the video are both interactive. So for example, if I click on a thumbnail on the driving direction, this will automatically pan and zoom the map and play that part of the video that corresponds to the turn. Here's another example where I click on another thumbnail, and the map will automatically pan, and the video will play me that part of that turn. I can also click on thumbnails on the video. So for example, I click on this thumbnail and the map automatically zooms out and zooms back in to show me this turn. In the user study, each participant is presented two techniques on two different driving routes. The two techniques correspond to the photo map on the left and the video map on the right. The two driving routes are different routes in Graz, Austria. The participant is given 5 minutes to learn the route using one of the interfaces. After using one of the techniques for 5 minutes, the participant is asked to take a simulated drive. In the driving simulation, arrows appear at each intersection, and the user is asked to indicate which direction to turn. We record the percent of successful turns and the number of times the user consults his or her printed driving directions. The results of the user study show that the participants that used the video map were more successful at navigating the turns, as shown on the left. Participants that used the video map also relied less on the printed driving directions, as shown on the right. The details are in the paper.